This is Brendan with Cusack Prep. This video is going to help you understand how you can use double angles to help you find solutions to trig equations. What I've written up at the top here are the double angle formulas for sine of 2 theta and cosine of 2 theta. Also on the right side, I've written the Pythagorean identity. The Pythagorean identity can be manipulated to help you get from one version of the cosine of 2 theta to the other versions. If you don't believe me, go ahead and try it for yourself. There's other videos covering that, so for now we're going to skip that. However, what I would like to talk about are these two problems down here. So for the bottom problem, we have cosine of 2x, negative cosine of 2x, plus 5 sine of x minus 2 is equal to 0. In order to solve this, we're going to need to use the double angle formula. So whenever you have a double angle formula, so cosine of 2x, and you have another trig function present in the problem, you have to change cosine of 2x into something else. So we're going to start with that. Now what I can see is cosine of 2 theta equals 1 minus 2 sine squared of theta. So I'm going to go ahead and change cosine of 2x into 1 minus 2 sine squared of x. And then we're going to have plus 5 sine of x minus 2 is equal to 0. At this point, we can go ahead and distribute the negative. So we're going to do that, and we'll have negative 1 plus 2 sine squared of x plus 5 sine of x minus 2 is equal to 0. Now, this is a quadratic. If you don't recognize it as a quadratic, we know it's a quadratic because we have a function of x squared, and we have just a function of x. So the sine squared of x and the sine of x allow this to be a quadratic. And anytime we have a quadratic, we want to put it in standard form, where we put our largest exponent value first. So in this case, that's going to be 2 sine squared of x, followed by our middle term. So this is going to be 5 sine of x. And then we can combine the negative 1 and the negative 2 to make a negative 3. All of this we can go ahead and set equal to 0. Now, after this, we have to factor, because that's what we typically do in order to solve quadratics. So to factor this, we're going to take our first term, which is 2, and we're going to multiply by our last term, which is negative 3. When we do that, we end up getting negative 6. And then we need to find two factors of negative 6 that add to positive 5. So I know that I can turn this into a positive 6 and a negative 1. So I'm going to go ahead and get rid of that really quick. But what I'm going to do with that positive 6 and that negative 1 is I'm going to split up the middle term. So I'm going to write my first term the same, still 2 sine squared of x. But instead of writing 5 sine of x, I'm going to write plus 6 sine of x, and then minus 1 sine of x minus 3 is equal to 0. We then proceed to factor by grouping. So that involves putting the first two terms in parentheses, as well as the second two terms in parentheses. Now out of the first term, I can take a 2 sine of x out. And what I'm left with inside of the parentheses is sine of x plus 3. Now out of the second term, I can take a negative 1 out. And it has to be a negative 1, because that's going to leave what's inside of the parentheses will be the same in both sets of parentheses. At this point, we can see that our equation can be fully factored into 2 sine of x minus 1. So it would be 2 sine of x minus 1. And then also sine of x plus 3 is equal to 0. Once we're in our factored form, we can set each of the factors equal to 0 separately. This is going to leave us with 2 sine of x minus 1 equals 0, and then also sine of x plus 3 is equal to 0. Solving this for sine of x, we find sine of x is equal to 1/2. And solving this, we find sine of x is equal to negative 3. Now at this point you should know that sine of x equals negative 3 is not a solution, because sine of x can only range from negative 1 to 1. However, sine of x is equal to 1/2, and we typically describe the solutions just on the interval from 0 to 360, or more commonly 0 to pi. Now, sine of x is going to equal 1/2, where x is equal to pi over 6, or where it's equal to 5 pi over 6. And if you don't understand that, go back and review the unit circle and some of the basic trig identities. So that's how you do the problem on the left. For the problem on the right side up here, we have sine of 2x minus root 3 cosine of x is equal to 0. So once again, we're going to have to use the double angle formula at the top. In here, sine of 2 theta is equal to 2 sine of theta times cosine of theta. So instead of sine of 2x, I'm going to write this as 2 sine of x times cosine of x minus the square root of 3 times cosine of x is equal to 0. Once again, we can factor this, even though it's not a quadratic. We can factor this one by taking out the greatest common factor in both terms. Each of these terms has a cosine, so I can take a cosine out of both. So if we take a cosine out of the first term, we're left with 2 sine of x. And if we take a cosine out of the second term, we're just left with root 3. Just like in the last problem, we can set each of these factors equal to 0 separately. So we're going to have cosine of x is equal to 0. And we're also going to have 2 sine of x minus root 3 is equal to 0. For both of these problems, from the unit circle, we would know that where cosine of x is equal to 0, that happens where x is equal to pi over 2, as well as 3 pi over 2. This one turns into sine of x is equal to root 3 over 2. And we know that that happens where x is equal to, has to be in the first and second quadrant, so pi over 3, and then also 2 pi over 3. And that's it. That's 2 separate examples of how you can solve trig identities involving double angles for sine and cosine. Thanks for watching.